Curve with the equation y equals f of x is such that f prime x equals 2x to the minus third minus x to the third. It's given that f of 8 equals 5, and we are required to find f of x. Okay, so we are given a derivative function, and we are required to find the function itself, f of x. So we need to integrate this expression. So we're going to integrate f prime x Okay, so that equals, choose a constant. We're integrating x to the minus a third, so we're going to be adding 1 to minus a third, which gives us 2/3, and we divide by 2/3, minus x to the third plus 1 will be 4/3, and we divide by 4/3, and we also have to add the constant of integration c. And the left hand side is the function y, or rather f of x. So 2 divided by 2/3 is the same as 2 times 3 over 2. So that will just be 3x to the 2/3 minus 1 divided by 4/3 will be 3/4 x to the 4/3 plus c. Now we are told that f of 8 equals 5. So when x equals 8, y or f of x will be 5. So 5 equals 3 times 8 to the 2/3 minus 3/4 times 8 to the 4/3 plus c. So 5 equals 3 times 2 cubed to the 2/3 minus 3/4 times 2 cubed to the 4/3 plus c. 5 equals 3 times, that'll be 2 squared, which is 4, minus 3/4 times, that'll be 2 to the 4, which is 16, plus c. That'll be 3/4 of 16 is 12. So c equals 5. So the function f of x would be 3x to the 2/3 minus 3/4 x to the 4/3 plus 5. The curve has equation y equals x squared plus 2cx plus 4. When a straight line has equation y equals 4x plus c, where c is a constant. We're required to find the set of values of c, which the curve and the line intersect at two distinct points. The two functions to intersect at two distinct points, the discriminant delta must be greater than 0. So this is what we are looking to do, right? We're going to equate the two functions. Establish a simplified expression with one side of the equation equal to 0. So x squared plus 2cx minus 4x plus 4 minus c equals 0. This expression over here, we're going to determine the discriminant form. So a equals 1. The coefficient of x is 2c minus 4, and the constant term c is 4 minus c. Not ideal that we're calling it c equals 4 minus c, but nonetheless. Delta equals b squared minus 4ac. So that's 2c minus 4 all squared minus 4 times 1 times 4 minus c. So that's 4c squared minus 80 minus 80 minus 16c plus 16 minus 16 plus 4c. So delta equals 4c squared minus 16c plus 4c minus 12c, 16 minus 16. So this is the expression for delta, the discriminant. Now for these two functions to intersect at two distinct points, delta must be greater than 0. So we can now solve for c such that 4c squared minus 12c is greater than 0. And divide through by 4, so c squared minus 3c is greater than 0. You can take out a common c. C times c minus 3 is greater than 0. So the critical values, c equals 0 and c equals 3. Let's just draw a sketch. We'll do it algebraically as well. But a nice solution to finding a nice approach to finding the solution to a quadratic inequality is by using a sketch. So these critical values are your x-intercepts at 0 and 3. That will be your axis of symmetry. We're not really too phased about the turning point. We just know that the function is pointing up because the value of the coefficient of the squared term is positive. It's positive 4. So the quadratic will point up. We are now looking for positive y values. So in this region here, when x is less than 0, the function points up, and in this region over here, for x greater than 3, the function points up. So the function is positive for x values less than 0, and the function is positive for x values greater than 3. So that is the solution. X is less than 0, or rather it's not x, right? It's c. Now variable is c here. C is less than 0 or c is greater than 3. And that is the solution. If you want to solve it algebraically, then on a number line, place the critical values 0 and 3. The inequality is exclusive, so we have open circles above each critical value. Because the square term is positive, we start with a plus on the right of the most positive critical value and alternate the signs as we move left. So we start with a plus to the right of 3 and alternate the signs. This is a foolproof method. You don't need to know the details of the approach. And because the inequality is greater than 0, we now point an arrow in the regions we've marked with the plus sign. So, sorry, not x. C is less than 0 or c is greater than 3. You get the same solution whether you draw a sketch graph or do it algebraically. For the following two questions, we're required to find the term independent of x in each of the expansions. So 3x plus 2 over x squared to the power of 6. When we expand this, we'll have 6 choose 0, 3x to the power of 6, plus, second term will be 6 choose 1, 3x to the power of 5 times 2 over x squared. And we don't have to put to the power of 1, but I'm going to do that. Then plus 6 choose 2, 3x to the power of 4 times 2 over x squared, plus 6 choose 3 times 3x to the power of 3, 2 over x squared to the power of 3, plus 6 choose 4, 3x squared times 2 over x squared to the power of 4, plus 6 choose 5, 3x to the power of 1 times 2 over x squared to the power of 5, and finally the last term 6 choose 6, and that'll be 2 over x squared to the power of 6. Now we are required to find the term independent of x. So we cannot have a term that contains an x, in other words, right? So we're clearly not looking at this term. We're not looking at that term either, because when we multiply this out, we've got an x to the 5 times 1 over x squared, which is x cubed. So we can forget about that term as well. This term over here, we've got x to the 4 times, don't worry about the coefficients here, 3 and 2, right? We're just looking at the x terms. We have 1 over x squared, so that's x to the 4 times 1 over x to the 4, which is going to cancel. This term does not contain a term in x because the x terms are going to cancel. So this is definitely what we're interested in. I'm going to continue through the rest of the terms just to make sure that we haven't left anything out. So this term over here will have an x cubed times 1 over x squared cubed, which would be x to the 6. That's going to give us 1 over x to the 3. This contains an x term, so we don't worry about that. We'll have an x squared over here and 1 over x to the 8. We've got a term in x, so we're not interested in that term either. And the same will be here. Same can be said of here. We have x times 1 over x to the 10. Not interested in that, and this is also going to contain a term in x. So this is the only term that we are concerned with. Okay, so we'll just evaluate this now. So 6 choose 2 is going to be 6 times 5 over 2 times 1. You can use the factorial notation if you like, or Pascal's triangle to evaluate the coefficient of this particular term. So this is 6 factorial over 2 factorial times 6 minus 2 factorial. 3 to the 4 is 81, x to the 4. And then we'll have 2 over x squared all squared, so it'll be 4 over x to the 4. Those terms cancel. That's 30 divided by 2. It's 15 times 81 times, and that equals 60 times 81, which is 4,860. Do likewise with this expression now. We've already established the expansion of the first binomial. And we are now multiplying essentially every single term by 1 minus x cubed. So the first term contains x. We need a term or terms that are independent of the variable x. When we take the first term multiplied by 1, we're going to get that term which contains x. And then you multiply it by minus x cubed and you still get a term in x. So the first term is not what we're looking for. The second term, we have x to the 5 times 1 over x squared, which is x cubed. And then we multiply it by 1 minus x cubed, and we still have a term in x, so that is also out. The third term, we have x to the 4 times 1 over x to the 4, which is 1. Right, and that's independent of x, and we multiply that by 1 minus x cubed. So we have that instance, right? And we've already established what that was. It was 4860. So we need to bear that in mind. This term here, we have x cubed times 1 over x to the 6, which is 1 over x cubed, and then we multiply that by 1 minus x cubed. Now, when we multiply that by 1 minus x cubed, we are going to get, when we multiply these two terms, we are going to get negative 1, which is independent of x. So we are interested in this term over here. All we're doing right now is highlighting the terms that are going to give us what we're looking for before we do anything else. Then the third last term, we have x squared, and we're just looking at the variable now. We're not looking at any coefficients or any other numerical values. X squared divided by x to the 8, which is 1 over x to the 6. And when we multiply that by 1 minus x cubed, we're going to get terms in x, so this is not going to give us what we're looking for. Second last term, we have x times 1 over x to the 10, which is 1 over x to the 9. And when you multiply it by 1 minus x cubed, you get terms in x, also not what we want. And likewise, the last term is 1 over x to the 12, not going to give us what we're looking for. So we're only interested in these two terms over here. Okay, so this expression here we've already established is 4860. You can refer to the previous question. Plus 6 choose 3 is 6 times 5 times 4 divided by 3 times 2 times 1 times 3 cubed is 27 x cubed times 2 cubed is 8 over x to the 6 it's 3060 divided by 3, that's 20 times 27 times 8 times 1 over x cubed. That's 4320 times 1 over x cubed. Now what we've done so far is we've only looked at this first binomial expansion. We extracted the terms that are independent of x, right? This is the first, that was part A, that was independent of x. And this term over here, 4320 divided by x cubed, will be independent of x once we've actually multiplied this entire expression by 1 minus x cubed. So that's what we're going to do now. 4860 times 1 will give us 4860. 4860 times minus x cubed, not interested in that because we're looking for a term that's independent of x, so we can ignore that. 4320 divided by x cubed times 1 gives us a term in x cubed, not interested in that either. But the last two terms will give us plus 4320 divided by x cubed times minus x cubed. And what that gives us, that x cubed will cancel with that x cubed, and we have 4320 times minus 1, so it's going to be minus 4320, which is both these terms are now obviously independent of x, so that equals 540, and that is the final answer. The first term of a geometric progression and the first term of an arithmetic progression are both equal to a. The third term of the geometric progression is equal to the second term of the arithmetic progression, and the fifth term of the geometric progression is equal to the sixth term of the arithmetic progression. Given that the terms are all positive and not all equal, find the sum of the first 20 terms of the arithmetic progression in terms of a. Okay, that's quite a lot to digest. So let's break it down. We have the GS, geometric sequence or progression, and arithmetic sequence. The first term in each is a. The third term of the geometric progression is equal to the second term of the arithmetic progression. Okay, so the second term of the the third term of the geometric progression equals AR squared, and the second term of the arithmetic progression equals A plus D. The fifth term of the geometric progression, T5, is AR to the 4, is equal to the sixth term of the arithmetic progression, so the sixth term is A plus 5D. Okay, so we have obviously A equals A, just writing these as equations. AR squared equals A plus D, and AR to the 4 equals A plus 5D. I now need to find the sum of the first 20 terms of the arithmetic progression in terms of A. So if we're going to find an expression purely in terms of A, we need to eliminate the variable D, which is what we're going to do. So D equals AR squared minus A. So we can sub that into this equation here. So AR to the 4 equals A plus 5 times AR squared minus A. AR to the 4 equals A plus 5AR squared minus 5A. AR to the 4 equals 5AR squared minus 4A. We can now divide through by A since it is a non-zero term. So R to the 4 equals 5r squared minus 4, r to the 4 minus 5r squared plus 4 equals 0, r squared minus 1 minus 4 equals 0, so r squared minus 1 equals 0, or r squared minus 4 equals 0, and then we can factorize using dots. R equals negative 1, or r equals 1, and then r plus 2 times r minus 2 equals 0, r equals minus 2, or r equals 2. Now, given that the terms are all positive, we cannot have a negative ratio, so we can immediately discard those two values of r. So the GS, first term is a, the second term is ar, and then the third term is ar squared. So it's going to be a. Now if r is 1, then we're going to have a. If r is 1, we can have a. This is not a sequence. That's definitely not a geometric sequence. So this is now not applicable. So r equals 2. We'll have a, ar, which will be 2a, and then ar squared. So it's going to be a times 2 squared is 4a. This is geometric because we are multiplying by 2. That is your common ratio 2. These terms are not equal, right? You cannot have a sequence a. That's not a geometric. It's not any kind of sequence. It's not geometric or arithmetic, right? So that's why we invalidated r equals 1. Your arithmetic sequence is a plus d, a plus 2d. Now to find d equals ar squared minus a. So it's a times r squared. R is 2. So it's going to be 4a minus a, which is 3a. So this is our common difference for the arithmetic sequence. So the sequence is a plus d, a plus 3a, so it'll be 4a, and then a plus 2d, 3a, a plus 6a, that's going to be 7a. So now we have our sequence, our arithmetic sequence in terms of a. So we want the sum of the first 20 terms of the arithmetic sequence. So n equals 20. The first term is a, and the common difference is 3a. So the sum to n terms is n over 2 times 2a plus d times n minus 1. The sum to 20 terms is therefore 20 divided by 2 times 2a plus d is 3a, and 20 minus 1 is 19. That equals 10 times 2a plus 57a, 10 times 59a. So the sum to 10 terms is 590a. Express 2x squared minus 8x plus 14 in the form 2 times x minus a all squared plus b. Okay, we are given a quadratic in standard form, 2x squared minus 8x plus 14, and we're required to express it in turning point form. So we can be completing the square. When we complete the square, the first thing we do is ensure that the coefficient of the square term is 1. It's not 1 in this case, the coefficient is 2. So we're going to take 2 out. We're going to divide each term by 2, which leaves us with x squared minus 4x plus 7 with 2 on the outside. We now add a bracket squared and subtract that same bracket squared. The contents of that bracket will be half the coefficient of x. Half of minus 4 is minus 2. And then the first 3 terms of that expression in the brackets forms a perfect square trinomial, which is x minus 2 all squared, and we can evaluate these terms here. plus 7 minus 2 all squared is 4. So that's just going to be plus 3. And now we can bring the 2 into the square bracket. So it's 2 times x minus 2 all squared plus 6. We could have stopped at this at this step over here, because this is in the required form, 2 square bracket x minus a all squared plus b close square brackets. But it's good form to bring the 2 into, generally speaking, bring the 2 into the square brackets. The functions f and g are defined by f of x equals x squared for x is an element of all real numbers, and g of x equals 2x squared minus 8x plus 14 for x is a real number. Describe fully a sequence of transformations that maps the graph of y equals f of x onto the graph of y equals g of x, making clear the order in which the transformations are applied. So f of x equals x squared, g of x equals 2x squared minus 8x plus 14. Now, there's a reason why in the previous question we were asked to complete the square. Not explicitly, but we were asked to express the quadratic in turning point form, which was 2 times x minus 2 all squared plus 3. And that is because we are transforming the function f of x, which equals x squared, into g of x. So the first thing we do in transforming f of x to g of x, we're going to start with the horizontal shift, the horizontal shift. Let's just start here. The value of p, if we write this function as x minus 0 all squared plus 0, then at least we've got something to compare to, right? We're looking at this function and that expression and this expression here. So from this, the way that we've written y equals x squared, p equals 0 and q equals 0, we're talking about the general quadratic in turning point form, which is y equals a times x minus p all squared plus q. So we're referring to this p and that q there. So p is 0 and q equals 0 for f of x. For g of x, p equals 2 and q equals 3. So we can describe this shift because p has increased from 0 to 2. So that means we've shifted 2 units to the right in going from f of x to g of x. And q has gone from 0 to 3. So there's been a vertical shift of 3 units up in going from f of x to g of x. So the first transformation in going from f of x to g of x will be 2 units right. Okay, this is in going from f of x to g of x, and 3 units up. So that's the first transformation, is the horizontal and vertical shift. But now we've also got this 2 to consider as well. Okay, the transformation after the horizontal and vertical shift is a stretch. It's a vertical stretch indicated by the 2 outside those square brackets. So we will have a stretch, the scale factor of 2, and this is parallel to the y-axis. So the full transformation will be f of x is shifted 2 units right and 3 units up, and then it is stretched by a scale factor of 2 parallel to the y-axis. Circle with the equation x plus 1 all squared plus y minus 2 all squared equals 85, and the straight line with the equation y equals 3x minus 20 are given. The line intersects the circle at A and B, and the center of the circle is point C. We're required to find the coordinates of A and B. Now, since A and B represent the points of intersection, we equate the two relations. So, in other words, we're going to take the expression y equals 3x minus 20, and we're going to substitute it into the circle where we have y. So x plus 1 all squared plus, we'll open up square brackets here, we'll have 3x minus 20, which represents y, minus 2 all squared equals 85. So x squared plus 2x plus 1 plus, I'm just clean this up inside square brackets, 3x minus 22 all squared equals 85. X squared plus 2x plus 1 plus, expand this out, multiply this out, 9x squared minus 66x minus 66x is minus 132x plus 22 squared, 484 equals 85. That'll give us 10x squared, 2 minus 132 minus 130x. Then we'll have 485 minus 85 will just be 400. So we have a quadratic 10x squared minus 130x plus 400 equals 0. We can divide every term by 10. So x squared minus 13x plus 40 equals 0. Then the factors of 40 that will add up and give 13 be 5 and 8. So we have x minus 5 times x minus 8. X equals 5 or x equals 8. Now looking at the diagram, A lies to the right of B. So B's x coordinate will be 5 and A's x coordinate is 8. And then to find the y coordinates of A and B, we're just going to substitute into the simplest equation, which in this case is the straight line. So y equals 3 times 5 minus 20. 15 minus 20 is minus 5. So B is the point 5 minus 5. And A, y equals 3 times 8 minus 20. 24 minus 20 is 4. So y equals 4. A is the point 8, 4. Now it's always a good idea to check your work. We've already established that A lies to the right of B, so its x coordinate is greater. B lies underneath the x-axis, so its y value is negative. And A lies above the x-axis, so its y coordinate is positive. Next, we're required to find the equation of the circle that has the center being point C, and for which the line y equals 3x minus 20 is a tangent to the circle. So let's just look at this again. We have the circle, and we have the straight line, y equals 3x minus 20. Now, we need this line, which intersects the circle at two distinct points. We've already established what the coordinates of those points were, point A and point B. Now, for the line y equals 3x minus 20 to be tangential to a circle, not the same circle that we're looking at right now, but another circle that has the same center C. So we will have another circle, center C, so that's point C over there, center of the circle, and the line y equals 3x minus 20 will be a tangent to that new circle. So it will touch, say, point M. Now, if we draw in the radius, so in other words, a line segment from the center C to M, which is the point of contact between the tangent and the circle, so that's the radius. CM is the radius. Now we know that from Euclidean geometry theory that a radius is perpendicular to a tangent at the point of contact. So we can draw in this being this right angle over here, because we know that the radius is perpendicular to the tangent. If we now also just join C to A and C to B. Right, this angle here is also going to be 90 degrees. We have a common side. And when you consider that AC, now we're looking at CA, which is a radius, and I'm going to use a capital R, R1. AC is a radius of the larger circle, right? Because C is the center and A lies on the circumference. And by the same token, we'll have radius R1, CB. CA and CB are radii of the larger circle. So they're equal in length, right? So we've got these two triangles here. We've got triangle AMC and triangle ACB. And we can clearly see we've got two sides, AC equals CB. We have equal angles here because we've got right angles here. And ACM rather is a common side. So we've got a side, a right angle, and the hypotenuse. So triangle AMC is congruent to triangle BMC, right angle, hypotenuse, side. So in other words, we know that AM equals MB. And therefore, M is the midpoint of AB. We have to do all of this because we have to show that M is the midpoint. We can't just assume just because it looks like it. We actually have to prove that M is the midpoint of AB. And now that we know the coordinates of A and B, A is 8, 4, B is the point 5 minus 5. We can determine the coordinates of M using the midpoint formula. So the midpoint of AB will be 8 plus 5 over 2, 4 minus 5 over 2. So that's 13 over 2 and minus 1 over 2. We now need to find the equation of the smaller circles. So the center of the circle is the point 1, rather minus 1, 2. And we need to know the radius, which is the length of CM. And we know we've just determined the coordinates of M, 13 over 2 minus 1 over 2. So the length of CM will be the square root of 13 over 2 plus 1 all squared plus minus a half minus 2 all squared, and that equals the square root of 225 over 4 plus 25 over 4, the square root of 250 over 4, which is the square root of 125 over 2. We now have the center of the smaller circle and the radius cm. So this is your radius, root 125 over 2. So the equation of the smaller circle is therefore x plus 1 all squared plus y minus 2 all squared equals r squared. So the square of root 125 over 2, which is just 125 over 2. And that's the equation of the smaller circle. Question 7. Show that sine theta plus 2 cos theta all over cos theta minus 2 sin theta minus sine theta minus 2 cos theta divided by cos theta plus 2 sin theta equals 4 divided by 5 cos squared theta minus 4. Okay, a general rule of thumb with all trigonometric identities is to start with the more complex side of the equation. So we're going to start with the left-hand side. The first thing we're going to do is establish a denominator. So we need to get the LCM between these two individual denominators, which is cos theta minus 2 sin theta times cos theta plus 2 sin theta. And in the numerator, we're going to have this expression sin theta plus 2 cos theta times cos theta plus 2 sin theta. Minus this expression sin theta minus 2 cos theta times cos theta minus 2 sin theta. The other thing we can do now is multiply out these brackets. So we'll have sine theta cos theta plus 2 sine squared theta plus 2 cos squared theta plus 4 sine theta cos theta. We'll just bracket that for now, minus sine theta cos theta, and we'll bracket again, sine theta, and it's imperative that you do use brackets here because we have a minus sign that precedes those brackets. Sine theta times minus 2 sine theta minus 2 sine squared theta minus 2 cos squared theta plus 4 sine theta cos theta, and then that is all over. And we're going to multiply out. Generally speaking, you leave the denominator in factorized form, but if you look at the denominator on the right hand side, we've got a cos squared there, and we don't. The only way we can get a cos squared is by multiplying out these brackets. We're going to get a cos times a cos. So multiply out the terms in the denominator, cos times cos, and then cos times 2 sine theta is 2 sine theta cos theta minus 2 sine theta cos theta, and then minus 4 sine squared theta. Okay, now we need to clean this up. So we have sine theta cos theta minus sine theta cos theta, so that will be 0. Then we have 2 sine squared theta minus 2 sine squared theta, so it's 2 sine squared theta plus 2 sine squared theta, which is 4 sine squared theta. 2 cos squared theta minus 2 cos squared theta is 2 cos squared theta plus 2 cos squared theta, so that's going to be plus 4 cos squared theta. 4 sine theta cos theta minus 4 sine theta cos theta is 0. So numerator reduces to 4 sine squared theta plus 4 cos squared theta. In the denominator, we have 2 sine theta cos theta minus 2 sine theta cos theta. So we are left with cos squared theta minus 4 sine squared theta. Now, in the numerator, we can take out a common factor of 4. And we're left with sine squared theta plus cos squared theta inside the brackets. And then in the denominator, we've got cos squared and sine squared theta. But if you look at the right-hand side, we have only cos squared theta present in the denominator. So we're going to express sine squared theta as 1 minus cos squared theta. Recall the square identity, sine squared theta plus cos squared theta equals 1. So the numerator, we just have 4 sine squared theta equals, if we take that term across to the right hand side, 1 minus cos squared, so that's where we got that from. So we have 4 over cos squared theta minus 4 plus 4 cos squared theta, and that equals 4 over cos squared theta plus 4 cos squared theta is 5 cos squared theta minus 4, and that equals the right hand side. Okay, part B is to solve the equation for theta is an angle between 0 and 180 degrees. Now we have just shown that this expression here on the left hand side equals 4 over 5 cos squared theta minus 4. That was the whole purpose behind expressing this expression in terms of a single trigonometric function. So we can now use that to solve this equation. So we can multiply both sides by this denominator. So 4 equals 5 times 5 cos squared theta minus 4. 4/5 equals 5 cos squared theta minus 4. 5 cos squared theta equals 4/5 plus 4, which equals 24 over 5. Cos squared theta equals 24 over 25. And to solve, to get cos theta, we're going to square root both sides. So we'll get plus minus the square root of 24 over 25. And then the plus minus here means that our solution, the domain is theta lies between 0 and 180 degrees. Cos is positive in the first quadrant and it's negative in the second quadrant. We're only looking at these two quadrants because that's the domain 0 to 180 degrees. So the reference angle will be theta equals shift cos root 24 over 25. So theta is 11.54 degrees. The first solution will be in the first quadrant, that is the acute angle. So theta is 11.54 degrees, or theta is in the second quadrant, 180 minus 11.54 degrees, which is 168.46 degrees. Question 8. The diagram shows a circle with the equation x minus 2 all squared plus y squared equals 8. The chord AB of the circle intersects the positive y-axis at A and is parallel to the x-axis. We're required to find the coordinates of A and B. Okay, so to find the coordinates of A and B, we need to know the defining equation of the circle, which we do know, x minus 2 all squared plus y squared equals 8. But we also need to know what the defining equation of the line segment AB is. Now, AB is a horizontal line, obviously parallel to the x-axis. So it's a y graph, right? So this line AB passes through the y-axis at A, and we need to know what the coordinates of A are. Once we find out what the coordinates of A are, we know what the defining equation of the line segment AB is. Now, A lies on the y-axis, so it's a y-intercept, and y-intercepts have x equal to 0. So we're going to take the circle. The circle passes through point A. So to find the coordinates of point A, we put x equal to 0. So 0 minus 2 all squared plus y squared equals 8. We'll have y squared plus 4 equals 8. Y squared minus 4 equals 0. We factorize that. Y plus 2, y minus 2, y equals minus 2, or y equals 2. Now, you can clearly see that the circle cuts the y-axis at 2 points, at A, and we can call this point over here, we'll call that point C. A's y value is obviously positive because it lies on the positive y-axis, and C's y value lies on the negative y-axis. So clearly, C is going to be the point 0, minus 2, and A will be the point 0, 2. So we have the coordinates of A. Now B will have the same y coordinate as A because A and B lie on the horizontal line AB, which is a y graph. The line segment AB passes through the y-axis where y equals 2 at point A. So to find the x coordinate of B, we're going to substitute B's y coordinate, which is 2, into the circle. So x minus 2 all squared plus 2 squared equals 8. X minus 2 all squared equals 8 minus 4, which is 4. We square root both sides. X minus 2 equals plus or minus 2. X equals 2 plus or minus 2. So therefore x equals 2 plus 2, which is 4. Or x equals 2 minus 2, which is 0. Now, where x equals 0, this is the point 0, 2, which means that B is the point 4, 2. So A is 0, 2 and B is 4, 2. Next, we are required to find the volume of revolution when the shaded segment, bounded by the circle in the chord AB, is rotated through 360 degrees about the x-axis. So we are going to have a reflected segment over here. We call this line segment CD. When we rotate the shaded region bound by the circle and the chord AB about the x-axis, we are going to form a disk washer model which has cross-sectional circular cuts So we're going to have an outer radius, which is from the circle to the center, which lies on the x-axis. So from the outer circle to the x-axis, and that will be radius r1. And then the inner radius will be from the straight line to the center of the circle, and that will be, we'll call that small r. We can actually just call this capital R. So because we have an inner and an outer radius, we will have pi capital R squared for the area of the larger cross-sectional circular cut. So that will be the outer circle minus the area of the inner circle. So that will be pi lowercase r squared, and this is all integrate with respect to x. So we integrate from x equals 0 to x equals 4. We can take this pi out as a constant, and we will have capital R squared minus small lowercase r squared dx. So that will equal pi times integral from x equals 0 to x equals 4. The radius squared, the outer radius, the radius of the larger circle, circular cut, will be the equation of the circle, right? And this has to be y in terms of x. So we are going to need to express the circle as follows. First we isolate y squared, so it will be 8 minus x minus 2 all squared, and then we square root both sides. So it will be the square root of 8 minus x minus 2 all squared. And because it's the difference between the circle, the y values on the circle to the center of the circle, which is on the x-axis where y equals 0, the outer radius will just be this expression, the square root of 8 minus x minus 2 all squared. And we're going to square that, so it'll be r squared, so we're just going to lose that square root bracket, so it'll be 8 minus x minus 2 all squared. So this is your uppercase r squared less r squared, which is the lowercase, so that is from the straight line where y equals 2 less y equals 0, so it's going to be 2. 2 squared will be 4, and then this is integrated with respect to x. Okay, so that will equal 5 times the integral from x equals 0 to x equals 4. 8 minus, open brackets, x squared minus 4x plus 4 minus 4 dx. And that simplifies to pi times the integral from x equals 0 to x equals 4 of minus x squared plus 4x dx. Then we just need to integrate that, so we'll have pi times minus x cubed divided by 3 plus 4x squared divided by 2, and that's evaluated from x equals 0 to x equals 4. That equals pi times minus 4 cubed, so minus 64 divided by 3 plus 2x squared, so it'll be 2 times 4 squared, 2 times 16, 32, less, when x equals 0, then these terms are just going to be 0. So that'll be pi times, it's going to be 32 over 3. So the volume is 32 pi by 3 units cubed. Question 9. Functions f, g, and h are defined as f of x equals x minus 4x to the half plus 1, g of x equals mx squared plus n, and h of x equals x to the half minus 2. We're required to solve the equation f of x equals 0, giving the solution in the form x equals a plus b root c, where a, b, and c are integers. So f of x equals x minus 4x to the half plus 1. X is greater than or equal to 0. Now, we need to solve the equation x minus 4x to the half plus 1 equals 0, since we're looking for f of x equals 0. This is now a quadratic with fractional indices. So what we're going to do is use a substitution. We're going to let x to the half equal p. You can use any letter except x. And therefore x will equal p squared. So we're going to rewrite this expression here as p squared minus 4p plus 1 equals 0. Now this should be a very big hint over here. The fact that you have to write the solution in this form, x equals a plus b root c, means that you're not going to get a nice neat integer value for p, right? You're going to get an irrational solution. So we know that this is not going to factorize, so we're just going to use the quadratic formula. So p will equal minus b, so minus minus 4 is 4, plus minus the square root of b squared, minus 4 squared is 16, minus 4 times a times c, so 4 times 1 times 1, divided by 2a, 2 times 1 is 2, so we get 4 plus or minus the square root of 12 over 2, which is 4 plus or minus 12 is 4 times 3, so we'll have root 12 being 2 root 3 divided by 2. You can take out a common 2, so we'll have 2 times 2 plus or minus root 3, and that's all over 2. The 2's cancel, so p equals 2 plus or minus the square root of 3. Now we can't leave the solution here because this is a solution in terms of p, and we used a substitution. So we called p x to the half. So x to the half equals 2 plus or minus root 3. So x to the half equals 2 plus root 3, or x to the half equals 2 minus root 3. Then we're going to square both sides. So x will be multiplying this out. 4 plus 4 root 3 plus 3, x equals 7 plus 4 root 3, and then similarly we're going to square both sides over here, and we'll get x equals 4 minus 4 root 3 plus 3, so x equals 7 minus 4 root 3. Okay, given that f of x equals g of h of x, find the values of m and n. So we'll first find an expression for g h of x, g of h of x. So that'll be g of x to the half minus 2, which equals m times x to the half minus 2 all squared plus n. That's m times x minus 4x to the half plus 4 plus n. And this expression here equals f of x. So that will equal x minus 4x to the half plus 1. And we'll now bring the m into the brackets here. So we'll have mx minus 4mx to the half plus 4m plus n equals x minus 4x to the half plus 1. Now we're going to compare the coefficients of the terms on the left hand side and the terms on the right hand side. So if you look at the coefficient of x on both sides of the equation, we have m on the left, and the coefficient of x on the right is 1, so m will equal 1. If we now compare the second term, minus 4mx to the half to minus 4x to the half, clearly if m equals 1, we're going to get exactly the same term. So it just confirms the fact that m equals 1. Minus 4mx to the half equals minus 4x to the half. So these terms will cancel. So m equals 1. And then the constant term, 4m plus n, will equal 1. So 4m plus n will equal 1. M equals 1. So it's going to be 4 plus n equals 1, so n equals 1 minus 4, n is minus 3. Question 10. Diagram shows a circle, center A, and radius 5 centimeters, and a larger circle, center B, with radius 8 centimeters. The circles touch each other at point C, such that ACB is a straight line. The tangent at D in the smaller circle intersects the larger circle at E and passes through the center of the larger circle, B. We're required to find the perimeter of the shaded region. Okay, so firstly, the perimeter of the shaded region will be arc length DC plus arc length EC plus the length of DE. Okay, so the arc length DC, let's just start with arc length. So the arc length will be radius times theta. Now this angle over here we'll call theta, and then the angle over there we'll call alpha. So arc length DC will be the radius AD or AC times theta, and arc length EC will be radius, and we'll just call that capital R just to distinguish it from the radius of the smaller circle, times alpha. So BC or EB times alpha. Now we obviously need to determine, we've got the lengths of the radii of the smaller circle and the larger circle. We need to first determine the size of angle theta and the size of angle alpha before we can find the arc length of DC and arc length EC. To find DE, we have got a right angle triangle ABD. Since D is a tangent to the smaller circle and AD is a radius, and the radius is always perpendicular to a tangent at the point of contact. So we have a right angle triangle. We know the length of AB. So with a right angle triangle, we obviously thinking Pythagoras' theorem because we've got the lengths of sides here. So AB is given, it's 5 plus 8 is 13. AD is 5 because it's a radius, equal to AC. And BE is 8, which means if we just can call DE X, we don't have to. We can apply Pythagoras' theorem and get the length of BD, and then subtract 8 from it to get the length of DE. So that's where we're going to start. So AB squared equals AD squared plus BD squared. That's Pythagoras theorem. AB will be 5 plus 8, so it's going to be AB squared is 13 squared equals AD squared equals 5 squared plus BD squared. BD squared is 169 minus 25, so it's going to be 144, and therefore BD equals 12. So BD is 12 and BE is 8, therefore X or DE equals 12 minus 8, which is 4. Now to find the angles theta and alpha, we're going to use a trig ratio in the right angle triangle ABD. So we can start with theta. It really doesn't make a difference what we start off with. So theta, relative to theta, BD is the opposite side, which is 12. And AB is the hypotenuse, which is 13. And opposite over hypotenuse is the ratio sine, so that equals sine theta. Now just make sure that you're working in radians, because arc length and the area of a sector is always determined when your arc angle is measured in radians. So shift sine 12 divided by 13. So theta equals 1.176 radians. And likewise, we can either subtract pi by 2, 1.176 from pi by 2. So alpha equals 0.395. Alternatively, you can use another trig ratio. So we'll use 5 over 13, which is opposite over hypotenuse. So sine alpha will be 5 over 13, and then shift sine 5 divided by 13. Alpha is 0.395 radians, so it's the same thing. We now need to determine the arc length DC, so the radius for this sector for sector ADC, the radius is 5 and theta is 1.176. So the arc length DC is 5.88, and similarly the radius for arc length for the sector BCE, the radius is 8 and alpha is 0.395 radians. So that equals arc length EC is 3.16, and then the sum of these two arc lengths in DE will give us the perimeter of the shaded region, so 5.88 plus 3.16 plus DE, which is 4, and that equals 13.04 centimeters. And that's the perimeter of the shaded region. Now the area of the shaded region will be the area of triangle ABD less the area of that sector. Just call it sector 1 for now, less the area of that sector, which we'll just call sector 2 for now. So the area of triangle ABD, which is a right angle triangle, will be a half the base times the height. The base, one of them AD and BD are the base and the height, doesn't matter which one is which. So half BD, BD is 12 and AD is 5, so that will be 30 centimeters squared. That's the area of triangle ABD. The area, we'll just keep it a sector 1. Okay, this is ADC. Let's call that sector ADC. The area of a sector is a half r squared theta. So the radius for that sector is 5. So half 5 squared times theta. Theta is 1.176. So the area of that sector, ADC, equals 14.7 centimeters squared. And then the area of sector BCE is a half r squared alpha. The radius is 8, so it's a half 8 squared times alpha, which is 0.395, which equals 12.64 centimeters squared. So the area of the shaded region will be 30 centimeters squared minus 12.64 centimeters squared minus 14.7 centimeters squared, which equals 2.66 centimeters squared. Question 11, it's given that a curve has equation y equals k times 3x minus k to the minus 1 plus 3x, where k is a constant. Find in terms of k the values of x at which there is a stationary point. Okay, so first things first, we have stationary points to a curve where f prime x or dy dx equals 0. The gradient function or the derivative function equals 0 at stationary points. So y equals k divided by 3x minus k. Rather, let's just leave it in this form, because because we're going to be differentiating the function. So dy dx equals minus k times 3x minus k to the minus 2 times the derivative using the chain rule of 3x minus k. So we're going to times by 3 plus the derivative of 3x, which is 3, and for stationary points dy dx equals 0. So that all equals 0. Just clean it up a bit. We have minus 3k divided by 3x minus k squared equals minus 3, just taking that across there. We can divide both sides by, or multiply both sides by a minus sign. So we'll have 3k over 3x minus k all squared equals 3. 3k equals 3 times 3x minus k all squared. We can cancel these 3's over here. So k equals 3x minus k all squared. Since we want x in terms of k, we're going to square root both sides now. So we'll have the square root of k plus or minus the square root of k equals 3x minus k. 3x equals k plus or minus the square root of k, and x therefore equals k plus minus root k divided by 3. The function f has a stationary value at x equals a and is defined by f of x equals 4 times 3x minus 4 to the minus 1 plus 3x, for x is greater than or equal to 3 over 2. Find the value of a and determine the nature of the stationary value. Okay, so f of x equals 4 times 3x minus 4 to the minus 1 plus 3x. F has a stationary value at x equals a, so we're going to differentiate this function and equate it to 0. So we'll have minus 4, f prime x is minus 4 times 3x minus 4 to the minus 2 times 3 plus 3, and that will equal 0 for the stationary point. So we'll have minus 12 over 3x minus 4 all squared plus 3 equals 0. Now, we have a stationary point at x equals a, so we're really just going to be replacing this x with a, right? So this is all evaluated. This is really going to be evaluated. F prime a will just be this entire expression, just replacing the x with a, and then we're just going to solve for a. So this is the same equation as we had. This is the solution that we had, x equals k plus or minus root k over 3. That was x in terms of k. Now, in this case, instead of going through and solving this equation again, we just need to see what the similarity is between the two. So we had y equals k times 3x minus k to the minus 1 plus 3x. Our function is 4 times 3x minus 4 to the minus 1 plus 3x. So clearly, k, comparing these two, k equals 4. So we just need to look at the solution. X equals k plus or minus root k divided by 3, which will be the solution to that equation there. This with k equal to 4. So x equals 4 plus or minus root 4 divided by 3. So it's 4 plus or minus 2 divided by 3. X is 4 plus 2 divided by 3. 6 over 3 equals 2. Or x equals 4 minus 2 divided by 3. So that would be 2/3. X is 2, or x equals 2/3, which is really now the value of a. Since we had the stationary value was where x equals a. So a equals 2, or a equals 2/3. But now recall that the domain here is x is greater than or equal to 3 over 2. So x must be greater than or equal to 1.5. So 2/3 is clearly not applicable. So the value of a is 2. Now to determine the nature of the stationary value, we need to find the double derivative. So we need to find the double derivative where a equals 2. So we're just going to differentiate the first derivative. we're now going to find the second derivative. So f double prime a will be minus 12 times minus 2, 24 times 3a minus 4 minus 2 minus 1 is minus 3. Then we have to multiply by the derivative of 3a minus 4, which is 3. The derivative of a constant is 0. So the double derivative is therefore 24 times 3, which is 72 divided by 3a minus 4 cubed. And then f double prime 2, so where a equals 2, the second derivative will be 72 divided by 3a. 3 times 2 is 6. 6 minus 4 is 2. 2 cubed is 8. 72 divided by 8 equals 9, which is clearly greater than 0. Therefore, we have a minimum stationary point where a equals 2. Next, the function g is defined by g of x equals minus times 3x plus 1 to the minus 1 plus 3x for x is greater than or equal to 0. Determine whether g is an increasing function, a decreasing function, or neither. Now, for a function to be increasing, then the derivative function must be greater than 0. And for a function to be decreasing, the derivative function must be less than 0. So we're going to find the derivative function of g of x. So we're going to be looking for g prime x, which equals minus times minus 1 is 1, and then 3x plus 1 minus 1 minus 1, so that'll be to the power of minus 2, plus the derivative of 3x, which is 3. Now, this function g prime x, if it's greater than 0, then we'll have an increasing function. If it's less than 0, we have a decreasing function. If it's neither, then it's neither increasing nor decreasing. So I'm just going to write this slightly differently. That's going to be 1 over 3x plus 1 all squared plus 3. Now, we aren't given any more information here, so we have to determine whether g prime x is positive, negative, or neither. So by neither, we would have to have conflicting solutions. So for a particular value of x, the function will increase, and for another value of x, the function will decrease. That's an example of a function that is neither increasing nor decreasing, because for a function to be increasing, the first derivative function has to be positive, greater than 0 for all values of x. It can't just be positive for some values and negative for some values. So we need to determine whether g is an increasing function or a decreasing function or neither. So if we just look at this expression here, if we just look at that expression over here, 3x plus 1 on its own, we couldn't tell if, because it would depend on the value of x, whether 3x plus 1 on its own is positive or negative. But the fact that we are squaring this bracket 3x plus 1, the square of any number is always positive. So this entire bracket is always positive regardless of the value of x. If x is 0, then we have 1 squared, which is still greater than 0. So this is always a positive number. Now 1 divided by a positive number, it's still positive. It's a fraction. It's a small fraction. It's a small valued number because it is a fraction. You've got 1 divided by a large denominator. But regardless, it's still a positive number. So 1 over 3x plus 1 all squared is still positive. And then we're adding 3, so we're even more positive. So therefore, g prime x is positive. It's greater than 0 for all values of x. Therefore, g of x is an increasing function.